There's a silent crisis unfolding right under our feet, one that really threatens India's food security and the lives of millions. And no, it's not about pests or drought, it's about the very ground that sustains us. We're talking about problem soils, a massive, hidden challenge that we absolutely need to understand. So let's dig in. To really get a sense of the scale here, just look at this number: 90 million hectares. It's kind of hard to picture, right? Well, that's roughly the size of Germany and Poland combined. That is a huge area of India's farmland that's just not living up to its potential. And it doesn't stop there. On top of that, you can add another 6.73 million hectares of land that's struggling with too much salt. So you add all that up, and it's pretty clear we're not just talking about a few problem patches. This is a nationwide issue, and it really demands our attention. To tackle it, we need a clear game plan. All right, so here's how we're going to break this all down. First, we'll dive into the crisis itself. Then we'll meet the two main culprits: acidic soils and saline soils. After that, we get to the really exciting part, the solutions, and how we can literally turn barren land back into gold. And finally, we'll tie it all together and see why healthy soil means a prosperous future for everyone. Okay, so with India's population continuing to grow, the mission is crystal clear. We have to get more out of every single hectare of land. We just can't afford to have this much soil lying unproductive. Fixing these problem soils isn't just a nice idea, it's an absolute necessity for our food security. First up, let's talk about acidic soils. The best way to think about them is as sour earth. This is a huge problem, especially in areas that get a lot of rain, and it's kind of like a silent saboteur, undermining crop growth right from the roots up. So what is an acidic soil, really? Well, technically, it's any soil with a pH below 7.0. But here's the real kicker. It's a double whammy for plants. First, essential nutrients that plants need, like calcium, just get washed away. And second, harmful elements, like aluminum, become way more available, basically poisoning the plants. It's a tough situation. So you might be wondering, how does soil even get acidic in the first place? Well, there are four main culprits. Sometimes it just starts with the rocks the soil came from. They can be naturally acidic. Heavy rainfall is a big one, constantly washing away all the good stuff. Over time, using certain fertilizers can also push the pH down. And believe it or not, even the natural process of organic matter breaking down releases acids. This slide is a perfect way to see what's happening on a tiny, tiny scale. So, in healthy soil, think of the clay particles like little magnets, holding on to valuable nutrients like calcium. But in acidic soil, these pesky hydrogen ions come flooding in, and they're like stronger magnets. They literally knock the calcium off the clay and take its place. That all-important calcium then just gets washed away, leaving the soil pretty much useless. All right, let's switch gears and talk about our second big problem: saline and sodic soils. You see these a lot in India's drier areas. You might even know them by local names like Usar or Kalar. This is the salty earth, where a buildup of salts makes it incredibly tough for any plants to survive. So how does this even happen? It's actually a pretty simple process, especially when it's dry. You've got low rainfall, so there's not enough water to wash salts away, but you have high evaporation. This evaporation acts like a giant straw, sucking water from underground up to the surface. And that water is full of dissolved salts. The water evaporates, but guess what? The salt gets left behind. And that's when you see that white crust on the top of the ground. And this is where it gets really interesting for the science folks. Scientists have a system for classifying these salty soils. They look at three key things. First is electrical conductivity, or EC, which is just a fancy way of measuring how salty the soil is. Then there's something called the exchangeable sodium percentage, or ESP. That tells them how much of that salt is sodium, which is the really nasty kind for soil structure. And of course, they check the pH. By looking at these three numbers, they can get a precise diagnosis of what's wrong. So we've diagnosed the problems. And you're probably thinking, is there any good news? And the answer is a big yes. These conditions are not a permanent death sentence for the land. There is a clear treatment plan, and we can absolutely bring these soils back to life. And it really boils down to this simple idea. Each problem has a very specific chemical solution. For acidic soils, the enemy is too much acid, those H+ ions we talked about. The solution? You add a base, like agricultural lime, to neutralize it. Simple chemistry. For sodic soils, the villain is excess sodium. The fix? You add something like gypsum, which brings in calcium to kick that sodium out. And here's what that healing process looks like for acidic soil. When you add lime, the calcium ions go in and they basically take back their rightful place on those clay particles. They push out the hydrogen ions that were causing all the trouble in the first place. It's a simple exchange that completely restores the soil's balance and brings back its fertility. And for the salty, sodic soils, this quote from our source material just hits the nail on the head. The entire goal is to make a trade. You want to swap out the bad guy, the sodium that's destroying the soil, and replace it with the good guy, calcium. So if there's one hero in this whole story, it's gotta be gypsum. Chemically, it's just calcium sulfate. And why is it so popular? Well, it works, it's affordable, and it's easy to find, with huge natural deposits in places like Rajasthan. It's just a practical, powerful tool for farmers. Let's actually see this hero in action. On the left, you see the problem. All that sodium makes the soil structure collapse. The soil just clamps up, it gets hard, can't breathe, and water can't get through. But on the right, you see the solution. Gypsum is added. Its calcium swoops in and replaces the sodium. This opens the soil back up, allowing water to flow through and, most importantly, flush that harmful sodium away for good. Now, gypsum is definitely the go-to, but it's not the only player in the game. This table is really useful. It shows you how other amendments stack up. For instance, to get the same punch as 1 ton of gypsum, you'd only need about 0.186 tons of sulfur powder. This is super important information for land managers trying to figure out the most cost-effective fix. Okay, so we've gone deep into the problems and the solutions. Let's pull back now and talk about why this matters so much. Because at the end of the day, healthy soil is the bedrock of a prosperous future. I mean, the payoff for fixing these soils is just huge. You get better soil structure, it's softer, it drains properly, air and water can finally move around, key nutrients are suddenly available for plants to use. All the good little microbes that are the lifeblood of the soil can thrive again, and all of that leads to the ultimate goal: better crops and much higher yields. Look, if there's just one thing you remember from all this, let it be this: problem soils are not a permanent sentence. A diagnosis of acidic or saline soil is not the end of the story. These are treatable conditions. Science has given us the tools to diagnose the problem and the remedies to turn barren, unproductive land back into fertile, life-giving soil. And that really brings us to the final and maybe most important question. Knowing all this is the first step, but it's action that really creates change. So whether you're a farmer, a policymaker, or just someone who cares where their food comes from, the health of our soil is in all of our hands. What's the next step you'll take to keep it healthy?